As we begin to look at current problems in this video, the first thing is to have an understanding of what does it mean to be a current problem. The first thing that you have to understand about current problems is we're going to deal with two different rates, actually three different rates. Okay. Anytime there is something like water, okay, or air that has some sort of current, we're going to be dealing with the relationship between two different values. The first is the value in still water. This is if somebody was like in a pool, how fast would they be going? Or if a boat was on a lake where there was no current, how fast could they go? Okay, so that's the first rate. The second rate is the rate of the current. Okay, how fast is that current going? Okay, now it can either help you or it can hinder you, like if you're in the water or the boat's in the water. If you are headed downstream, which means you're going with the current, what's going to happen is the rate in still water, which a lot of times if it's a boat we'll use B, if it's a person we'll use P, or swimmer S. A lot of times the letter we use goes with what the object is. Okay, the rate of the boat in still water, okay, versus the current, since I want it to be higher, it's going to be added. If instead I'm heading down upstream or against the current, we're still going to be dealing with the same boat and the same current, but in this case we need it to be less, the actual rate to be less, so it's going to be subtracting. So B plus C would be a rate, B minus C would be a rate. Okay, the actual rate of how fast, if someone was standing on the shore looking at like a boat or a swimmer, how fast would it appear that they were going? The still water rate would be the actual potential of that object or that person to be able to travel. The current will either make it go faster or make it go slower based off that. So how does this apply? A classic example of this type of problem is that an airplane travels 2,000 miles in 4 hours. The return trip took 5 hours. What was the rate of the air current? And what would be the rate of the plane if there was no current? You could also imagine. Okay. In setting this up, you're still going to do rate, time, and distance. Okay. In this case, I could say that my rate is going to be the airplane plus the current and the airplane minus the current. Now here, if you need to think about where things would apply. If it's the rate of the airplane plus the current, the rate's going to be higher and it's going to be traveling faster, which means the time should be less. So I'm going to choose to put the 4 here and then the 5 here. Okay, the faster time should go with the plus sign, the slower time should go with the minus sign. Okay, the distance in this case in each way is going to be 2,000 miles. Okay, so what I would recommend thinking about this is using the fact that rate times time is equal to distance. Okay, so I could set this up as 4 times A plus C is going to equal 2,000. I could distribute this 4, but what's generally an easier thing to do is divide by 4 and get A plus C is going to equal 500. Now what allows me to do that? Well, if I think about this, instead of doing rate times time equals distance, my rate is going to be my distance divided by my time. So a lot of times, instead of working with the 4 times something, or the time times something, a lot of times it's easier if you do distance divided by time for these. Okay. So using that same idea, for the second equation, 2,000 divided by 5 would equal 400. So what that means is A minus C is going to equal 400. In this case, I'm going to add these. It's already set, the C's cancel out. 2A will equal 900. Divide by 2. The rate of my airplane is 450 miles per hour. Okay, so if I then plug it back in to one of my equations, let's plug it back in here. Okay, in this particular case, my 450 plus my C has to equal 500, so my air current is 50 miles per hour. Okay, one pretty simple example. A lot of times you are finding what that rate of the object is, rate of the boat, rate of the person, rate of the plane, as well as the air current, but there are times where you might have to find a certain time. Another example is a boat can travel at 50 miles per hour in still water or in a lake. Okay. If it takes the boat 4 hours to travel upstream 180 miles, how long will the trip home take? Okay, so you're going to set it up as a current problem. So rate times time will equal the distance. In setting it up, okay, I fill in what I know. Okay, going upstream against the current has to be a minus. Downstream with the current has to be a plus. If a boat can travel 50 miles per hour in still water, that's going to be the rate of the boat in both the places, but I do not know what the rate of the current is, so I'm going to fill in C. Okay. For the first, the trip upstream, I know that it takes 4 hours, so I can fill in the time, which means my distance will be 4 times 50 minus C, but I also know that that's going to equal 180. Okay. My time, this is what I'm trying to find. Okay. So this is a situation where if I look, I have one equation with one variable that I'm able to then go through and solve. So this would become 200 minus 4C is equal to 180. If I subtract 180 from both sides, I get 20. If I add 4C to both sides, I get 4C. Divide by 4, divide by 4. The rate of my current is going to be 5 miles an hour. What that means then is that I need to plug it into my second equation. Okay. My distance is still going to be 180, but instead of having C, I know my current is 5. So I have my downstream speed is going to be 55. What that means is then I can do 55 times a certain time will equal 180, and I divide by 55, divide by 55, and I get a really messy number. And for my answer, I get that T is going to equal 3.272727 repeated. So it's about 3 hours and 15 minutes. Which makes sense that it would be faster than if I was going upstream. Okay, so that would make sense. So that's basically current problems. So the biggest thing is with the setup to remember that you're doing the object plus the current if it's headed downstream, or with the current, and the rate of the object minus the current if it's headed upstream. Okay. Good luck.